Hello students, welcome back to another video. In today's video, we'll be doing another paper 4 of course code 0625. It's May-June year 2024 variant 2. So first question is saying a load is suspended from a thread. The vertical force on the thread due to the load is 0.75 Newton. Calculate the mass of the load. So there is a load of 0.75 Newton hanging with the thread and we are supposed to calculate the mass of this load. So weight is equals to mass times gravitational acceleration. And if you want to get mass, it would be weight divided by gravitational acceleration. Weight is 0.75 and g near the earth is 9.8. Dividing them both, you'll get your answer to two significant figure which is 0.77 kg. So here we have some kind of roof on which we have a string on which load is connected. A wire is attached to the load at point X and it is pulled horizontally towards right. The tension in the horizontal wire is 1.2 Newton. By drawing a scale diagram or by calculation, determine the magnitude of resultant force at X due to the load and due to the tension in the wire, and also calculate the direction of the resultant force relative to the vertical direction. So we are attaching another thread at point X and we are pulling this thread towards right side, and the tension produced in this thread is 1.2 Newton, and the tension in the first string that we already had is equals to the weight that is suspended to it, that is 0.75 Newton. So the resultant force would be this horizontal force, and we can calculate this by using Pythagoras theorem. Hypotenuse square is equals to base square plus perpendicular square. So I am just putting in the values. It would be 0.75 squared plus 1.2 squared. So the hypotenuse or the resultant would be 1.4 Newton. So I am writing 1.4 Newton over here. So we have got the magnitude, which is 1.4. Now what about the direction? What about this angle? So we can get this angle by using normal trigonometric function. This side is opposite and this side is adjacent. So we can use tan theta, which is opposite over adjacent. If you want to get angle, tan would be get reversed or inverse that side. Putting in the values 1.2 over 0.75, taking tan inverse of this fraction will give you 58 degrees, which is the magnitude, or sorry, the direction of this force. So 1.4 Newton and 58 degree is the final answer. C part is saying forces may produce change in the size and shape of the object. State two other changes that a force can produce or may produce. So force can do anything. Force can change the direction of something that is already moving, or force can change the speed of something. So I'm writing these two. You can write any you want to. Next question is saying define acceleration. So acceleration is basically the change in velocity of the body. Whenever a velocity of something increases or decreases, we say that it's accelerating. And to measure that acceleration, we measure the increase or decrease per unit time or per unit second. So it is rate of change of velocity, and in form of formula it is final velocity minus initial velocity divided by time or 1 second. B part is saying a train has a total mass of 520,000 kg. The train accelerates at 1.1 meter per second squared. Calculate the time taken for the train to increase its speed from 15 meter per second to 28 meter per second. So we have given with some factors. For example, we have given the initial speed or velocity, the final speed. We are supposed to get the time. We are also provided with acceleration. So we can use this formula that I have already mentioned. 1.1 28 minus 15 over time that we need to find. Arranging it with respect to time, time goes that side and 1.1 comes here. So time would be 12 seconds. Question number 2 is saying calculate the force required to produce an acceleration of 1.1 meter per second square for this train. So we need to get force and we have acceleration, and the equation that connects force and acceleration is F is equals to m times acceleration. Mass of the strain is given, that is 520,000, and the acceleration is 1.1. Multiplying these both is 572,000. Rounding it off to two significant figures, it is 570,000 Newton. Third part is saying train uses electric motor. Explain why the force on the train due to motor is greater than the value calculated in the part 2 that we have just calculated. It is 570,000, but the motor is producing a greater force. So where is the extra force of motor being used? For example, we have a train which is accelerating with 1.1 meter per second square, and this the force that is being applied on this train is 570,000 Newton, but the motor is producing a greater force. And where is the extra force of this motor going? So there are some environmental factors that are involved. For example, we have resistance in the air, so this extra force is used to cope this resistance which is acting in opposite direction. So I'm writing the reason for it. Force on the train due to motor is greater to cope the air resistance that is present in the environment. Question number 3 is saying a student drops a heavy ball from a vertical height of 1.8 meter above the ground. The ball then falls to the ground. It does not bounces after it hits the ground. Describe the transfer of energy of the ball between the stores from when the ball begins to fall and when it reaches the ground. So whenever there is a ball or something that is being at some height, for example, it is at 1.8 meter, it will have maximum potential energy at this point, and the kinetic energy of this ball is zero. And when it start falling towards ground, its height getting reduced, so its potential energy start converting into kinetic energy. And when the ball is just about to hit the ground, it has maximum kinetic energy and potential energy is zero, and all the potential energy has been converted into kinetic energy. And when it hits the ground, the kinetic energy converts into internal energy of the ball. Remember, at the height the potential energy was maximum, and all the potential energy converts into kinetic energy at the minimum height. So I'm writing at height 1.8 the ball has maximum potential energy, and then when the ball start falling, the gravitational potential energy start converting into kinetic energy of the ball. Before hitting the ground, the ball has maximum kinetic energy, and after hitting the ground, the kinetic energy converts into internal energy of the ball. B part is saying calculate the maximum speed of the ball and ignore the air resistance and show your working. So I've already told you that at this point the potential energy is maximum, and then it converts totally into kinetic energy. So we can say that all the potential energy is converted into kinetic energy. So potential energy is equals to kinetic energy. Potential energy has the formula mgh, and kinetic energy is half mv squared, and we want to get this v, maximum v. Mass is cancelled with mass, so gh is equals to 1 over 2 v squared, so v squared is equals to 2 gh, and for v we can take square root. Putting in the values, 2 times 9.8 times 1.8, the height is 1.8, so the maximum speed of this ball is 5.9 meter per second. Question number 4 says state two ways that evaporation is different from boiling. So evaporation can occur at any temperature, and also evaporation occurs at surface only. B part says figure 4.1 shows a part of container used to store a mixture of liquid and gaseous oxygen. So the temperature of liquid oxygen is negative 160 degrees Celsius. Determine the temperature of liquid oxygen in Kelvin. So we have liquid and gaseous oxygen filled in there, and the temperature of this liquid oxygen is 160 degrees Celsius, negative 160 degrees Celsius, and we need to convert it into Kelvin. So convert degrees Celsius into Kelvin, we have to add 273 Kelvin into the figure, and to convert Kelvin into degrees Celsius, we need to subtract 273 Kelvin. So I will add 273 into negative 160 degree, and the final answer is 113. To two significant figures, it would be 110 Kelvin. Second part says the container is made of steel and there is a vacuum between the inner and outer walls. The outer wall of the container is at room temperature. State two methods of thermal energy transfer that vacuum prevents. So, we know that heat is transferred by three methods: conduction, convection, and radiation. In conduction, the vibrations are passed on to the molecules, and this process is known as conduction. So, if there is a vacuum, there would be no molecule to pass on their vibration, and this will prevent conduction. And convection is the actual movement of particles from one place to another. So, vacuum will also prevent the movement of particles, but vacuum can't prevent a radiation. So, vacuum can prevent two things: conduction and convection. C part says describe in terms of particle how a gas exert a pressure on the walls of the container. So let's suppose we have a container and molecules are randomly moving here and there, and they also hits the wall of the container. So whenever they hit the wall of the container, they will exert force on the wall, and this force will generate pressure. That would be equals to force divided by the area. So molecules of gases are at random motion. They hit the wall of the container and apply force. This force create pressure that is equals to force per unit area. Question number 5 says figure 5.1 shows a ray of yellow light incident on a glass prism ABC. So there is a yellow light which is coming towards this prism, and it enters straight into the prism because it is parallel to the normal, or we can say it has 90 degree with the plane of the prism. So first question is saying explain why the ray does not change the direction when it enters the prism at the face AB. So the reason is because it is parallel to the normal or making 90 degree with the plane of the prism. B part is saying the critical angle of the glass is 42. Calculate the refractive index of the glass and show your working. So the formula that relate refractive index and critical angle is refractive index is equals to 1 over sine of critical angle. So I'll put the value of critical angle, which is 42. So refractive index is equals to 1 over sine of 42 degrees, and this will give you the answer of 1.5. Second question says on figure 5.1 continue the path of light through the prism and after it leaves the prism. Remember that critical angle of glass is 42 degrees. So firstly, at the point where the ray is falling, we have to check the angle of incidence. If it is greater than critical angle, the light will go total internal reflection, and if it's less than critical angle, then the light would be refracted, not reflected. So we will draw a normal first. For normal, you just grab your protector and make it 90 degree to the plane, and after it note the angle of incidence, which is 60. So it will have total internal reflection, and the reflected angle would be 60 again with the normal. So I have made a reflected ray, 60 incident angle and 60 reflected angle, and at this point of the plane it is again 90 degree with the plane of the prism, so it will go straight outside without going any reflection or refraction. Now, the C part is saying the internet data can be transferred using infrared waves in optical fibers. State two advantages of using optical fibers. So it is secure and it is fast. Thanks for watching my video. Stay tuned for part 2. If you like the video, please hit the like button and subscribe my channel.